Time to us is more than a number. It's a pulse, a passage, a law written into the architecture of our lives. We feel it in the wilt of flowers, in the grain of hair, in the way laughter echoes into silence and never rewinds. When yet the strangest thing about time is not how fast it moves, but that it moves at all. Most of nature doesn't seem to mind which way time flows. A planet can orbit forward or backward, gravity doesn't care. Electrons jump, photons fly, forces push and pull, perfectly symmetrical in time. So where does the difference come from? Why is there such a profound split between the past and the future? The answer lies not in the ticking of clocks, but in the changing of conditions, in the asymmetry of entropy. Time, in physics, is a parameter, but in experience, it's a direction. And that direction emerges not from cause and effect, but from the increasing number of ways things can rearrange themselves. Entropy doesn't just move energy, it sculpts time. Imagine you drop a glass. It hits the floor and shatters into jagged shards. Now picture the reverse, the shards rising, reassembling, and landing gently on the table. You know it's fake. Why? Because every moment in the real version involves energy scattering, complexity increasing, information being lost into heat and sound and randomness. The reverse would require those pieces to coordinate perfectly, every molecule tracing back its path. It's not impossible under physics, but it's so improbable, so statistically rare, that it might never happen even once in the lifetime of the universe. This is what makes entropy different. It's not a force. It's a statistic, and statistics have direction. The probability of a broken glass becoming whole again is not zero, but it's infinitesimal compared to the forward scenario. And here lies the quiet brilliance. Most of physics is ambivalent about time, but entropy is not. Bouncing ball, a pendulum, a spinning planet, they obey reversible laws. But when entropy enters the scene, when friction warms, when air molecules mix, when patterns dissolve, time gains a fingerprint. That fingerprint is not visible in the laws themselves, but in the outcomes they prefer. And entropy always prefers the future. The laws of motion are symmetrical. If you recorded two celestial bodies dancing around each other and reversed the footage, you'd see no violation. The math would still hold. The gravitational pull, the acceleration, the velocities, they all obey time-neutral equations. But real life is not so forgiving. In your kitchen, soup cools. In a thunderstorm, warm air rises and becomes scattered rain. In your cells, chemical gradients flatten. These things don't reverse not because they can't, but because they overwhelmingly won't. And that distinction is everything. The second law of thermodynamics tells us that entropy increases. It is an absolute edict, but is an overwhelmingly likely outcome. The universe is not forbidden from rewinding. It just doesn't. And so, entropy becomes the only known law that gives time its signature. This asymmetry shapes reality in quiet but total ways. A newborn cries. Entropy increases. A star fuses hydrogen. Entropy increases. You remember breakfast but not tomorrow's dinner. It's not because your neurons can't fire in reverse. It's because the storage of memory itself is a process that increases entropy by forming structure, by burning glucose, by pushing biological order outward into ambient disorder. We tend to think of time as a river, but entropy reveals its source. The past is a configuration with fewer possible microstates. The future is an ocean of probabilities, and that transition from fewer to more, from specific to general, is the slope of time. Memory is not a passive imprint. It's an act of entropy. To remember something, to record, store, retrieve information, your brain undergoes a cascade of molecular change. Neurons fire, chemicals shift, synapses adjust. And every one of those processes increases entropy. It's not because memory is messy, but because it is irreversible. To form a memory, your brain expends energy, gives off heat, and leaves the system more disordered than before. This is why you remember the past, but not the future. You might think, well, I can imagine the future, yes, but that's not memory. It's prediction, simulation, I guess. Memory is evidence, etched into biology, into molecules, into the very structure of matter. and that evidence only flows in one direction. This asymmetry is why it causes precede effects, why we see a rock thrown before we hear the splash, why the past feels settled and the future feels open. And this isn't just a human trait, it's universal. A hard drive, a tree ring, a fossil leech stores a record. But the act of recording always pays the entropy tax. But this raises an unsettling question. If entropy increases over time, why was the past so ordered to begin with? Why did the universe start low on the entropy scale? It's a puzzle that cuts deep because the early universe just after the Big Bang was incredibly hot and dense. And in thermodynamics, hot and dense usually means high entropy. But what made it low entropy was not temperature. It was structure war, rather, the lack of it. In those first microseconds, matter and energy were spread out almost perfectly evenly. No clumps, no galaxies, no black holes. And from a gravitational standpoint, that uniformity was incredibly ordered like a tightly wound spring. Over time, gravity amplified tiny fluctuations, forming stars, clusters, and voids. And with every step, entropy increased, so we find ourselves in a strange situation. The universe began with minimal structure, and out of that smoothness came the vast, evolving complexity we now observe. Galaxies swirl, stars ignite, brains think, all made possible because the cosmos started not in chaos, but in symmetry. It's beginning a low entropy. State gave entropy a runway. It gave time a slope. It gave stories a beginning. We say time flows. Entropy tells us it tilts. Imagine rolling a ball down a hill. The hill is steep, direction is obvious. You don't need a stopwatch to know which way is forward. Entropy provides that incline. It doesn't just govern heat, it governs sequence. The unfolding of events. The order of before and after. Without entropy, there would be no time as we know it. No cause and effect. No past to recall or future to imagine. Just a frozen block of possibility, symmetric, reversible, without change. Entropy fractures that symmetry. It gives the universe a gradient, a bias, a reason why the next moment isn't the same as the last. And that's what time is. It's not a tick on a clock, but a climb down the cosmic slope. So when you light a candle, hear a heartbeat, or watch a shadow stretch across the floor, remember this: what you are witnessing is entropy flowing, and with it, time.